Hello everyone. Today my friends and I will be sharing with you the wonderful reactions of the Briggs Rauscher oscillating clock. This reaction was discovered by two science instructors in a high school in San Francisco. The experiment begins by mixing three clear colorless solutions, which oscillates from an amber to dark blue color. The first solution contains potassium iodide and sulfuric acid dissolved in water. The second solution is malonic acid and manganese sulfate monohydride in water. And the last solution is hydrogen peroxide in water. The overall reaction goes like this. Iodide ions with hydrogen peroxide and malonic acid in the presence of sulfuric acid reacts to produce oxygen, water, and an iodine starch complex. As these reactions occur, the solution changes from colorless to amber to dark blue in a continuous cycle. I shall give my time now to Lin, who will discuss with you about the various reagents used in this experiment.
What are the reagents needed for this reaction to happen? We will need to prepare three solutions. The first solution will be solution A, which is made out of potassium iodate, sulfuric acid, they are dissolved in water. Okay, so to prepare solution A, we will add 43 grams of potassium iodate to 800 ml of distilled water. Then we will stir in 4.5 ml of sulfuric acid, and we will continue to stir until the potassium iodate is dissolved. From then, we will dilute the solution to 1 liter. Then for solution B, it is made out of malonic acid, manganese sulfate monohydrate, and starch that is dissolved in water. So to prepare solution B, we will add 15.6 grams of malonic acid and 3.4 grams of manganese sulfate monohydrate to 800 ml of distilled water. Then we will add in 4 grams of starch and stir until the starch is dissolved. From then, we will dilute the solution to 1 liter. Then for solution C is purely hydrogen peroxide dissolved in water. So we will dilute 400 ml of 30% hydrogen peroxide to 1 liter. So those are the three solutions that we need. So there are some things to take note when we are preparing the solutions, because if not, it will be harmful to ourselves. So in this demonstration involves the use of iodine, so there is a need for us to wear safety goggles and gloves to perform the demonstration, preferably under the ventilation hood, since the iodine is volatile. And we need to be more careful when we're preparing the solutions, because the chemicals involved in this solution in the solutions are strong irritants and oxidizing agents. So moving on, we will talk about the steps. We'll talk about the reactions that is involved in this reaction. So if you look at the poster under section A plus B then C, those are the steps that we need to perform. So the first step will be to put a stir bar into the beaker so that the solution will be well mixed later on. After that, we will add 300 ml of solution A, then 300 ml of solution B into the beaker. After we mix the solutions together, we will turn on the stir plate and adjust the speed of the rotation so that we can get a large vortex so that the solutions will be well mixed. Then as the solutions are being mixed, we will add 300 ml of solution C into the beaker. Once solution C is added in, the chemical reactions will start to happen, and you can see the color change from amber to blue, then back to amber for around 10 times until it ends with a blue-black mixture. Okay, so these are the steps, and moving on, Grace and Wansing will be talking about the mechanism that is used to explain the reaction.
Hi, I'm Grace, and now I'm going to take over from Lin. As you can see, under the section Chemical Reactions, the equations are references of the mechanism that I'm going to be talking about. The amber color results from the production of the iodine. The iodine forms because of the rapid production of the hypoiodous acid during the radical process. When a radical process is occurring, hypoidous acid is created faster than it can be consumed. Some of the hypoidous acid is used while the excess is reduced by the hydrogen peroxide to iodide. And now I'm going to pass over to Wansing to carry on.
Hi, I am Wansing, and now I'm going to take over from Grace. The increasing iodide concentration reaches a point at which the non-radical process takes over. However, the non-radical process does not produce hypoidous nearly as fast as the radical process. So the amber color begins to clear as iodine is consumed more quickly than it can be created. Eventually, the iodide concentration drops low enough for the radical process to restart so the cycle can repeat itself. The deep blue color is the result of the iodide and iodine binding to the starch present in the solution.